and welcome to our video on gradient of a straight line. Now you remember from previous years that the gradient is the steepness of a line. So if we have a line that is really steep, it's going to have a high gradient, so a high number. And if we have a line that is not very steep at all, then that will have a low gradient, a low number for a gradient. It can be useful to think of it as if someone is walking up this hill from left to right, this would be hard, so it would be a high rating. If they're walking up this hill, it's pretty easy, so it's going to have a low rating. Also, we need to remember that this graph has, so the first graph I've drawn has a positive gradient, and this one here is a negative gradient. Can be useful to think of this if you look at these two graphs and think about which one you would prefer your company to be having. If someone came to say this is how much money you're making, if you had a graph that looked like this that was going up, I would be really positive and really happy. So this one is positive, and if I had a graph that looks like this, I would be really sad and negative because I'd be losing lots and lots of money. Other people like to think of it as looking at towards the right hand side. Does it go up towards the positive, going up towards the sky, or this one towards the right hand side goes down into the negative if you extend it down to the right hand side? Up to you, but you need to be really clear about which one's positive and which one's negative. I've put some formulas that you will have used in the past up the top in this box. We use m to represent gradient. You can use rise over run, which is probably the first formula you were taught. You can also use m equals y2 minus y1 over x2 minus x1. And we're going to add a new one to that, m equals tan of theta. And this one works when theta is always measured from the positive x direction. So what that means is you take your line and you find positive x. This is positive x over here because it's positive 1, positive 2, positive 3. Over this side is negative x, negative 1, negative 2, negative 3. You take your line and you find the angle between the line and the positive x. So that's going to be your theta. This angle here, not theta. Don't ever use this angle for theta, for this formula. Has to be the angle between the line and the positive x direction. So this line here, the angle you would use would be between the line and the positive x. I've drawn a very big angle line there, but hopefully you get the idea. It's that angle, not this little one in here. I've got 3 examples here. You can at least have a go at 2, A and B, and if you have your notes you can have a go at C. Pause the video now. Okay, question A says calculate the gradient of the following. Because we can use any of these 3 formulas. It will be called M, so I can start with that. Because I've got a nice neat little triangle here looking something like this, I would be tempted to use rise over run. But if you wanted to use y2 minus y1 over x2 minus x1, because you're more confident with that, you could use 0, negative 3 as one point and negative 2, 0 as your second point, and this one would work as well. So rise over run, we've got, this is a negative graph because it's going down at the right hand side, so I'm going to put a negative to start. Rises up 3 and across 2, and there we go. The gradient is negative 3 over 2. Question B, a line joining these two coordinates. So really good example for y2 minus y1 over x2 minus x1. So we'll start by writing the formula, not y equals, m equals, and make sure it's a little m. Big M means midpoint, little m means gradient. M equals y2 minus y1 over x2 minus x1. I'm going to label these so I don't get confused. y2 is negative 4, take away 2, over 5, take away negative 3. I'm going to move across the page because I'm running out of room, but you would keep working down the page normally. Negative 4 take 2 is negative 6. 5 minus negative 3, this turns into a plus. 5 plus 3 is 8. And this will simplify to negative 3/4. So you could write your final solution here and put it in a box. Question C, I'm going to give you a minute to copy it and have a go yourself. You would need to convert this into degrees using the DMS function on your calculator. Or you could leave it like this, but you'd need to enter it like this using the degrees and the minutes key on your calculator when you are solving the problem. Pause the video now. Okay, let's have a look at this one. So we're going to use the formula m equals tan theta. And theta is this angle with the positive x direction. So I'm going to put over here some extra working. Theta will equal 180 take away 56 degrees and 19 minutes. You could put this straight into your calculator or you could convert it. I'm going to convert mine first of all. So when you convert this in your calculator, you get 56.32 degrees, and 180 minus 52.32 degrees is 123.68 degrees. So that's what this angle will be. So I can now use this formula, equals tan 123.68 degrees. Put all of this into your calculator, or conversely, if you had it in degrees and minutes, put that angle calculation into your calculator. Make sure you're entering it properly, and you should get negative 1.5. Good idea to just check, is this a negative gradient? Yes, so we would be expecting something, an answer that was negative. Thanks for watching the video.